These are the topics that you would cover during the CCNA training. So basically, this is recommended by Cisco to cover all these topics before you take on the CCNA exam. So in short, you can simply say that these are the topics that you need to cover. So first you have to cover the network fundamentals. That's one thing. So when I say network fundamentals, that means that you should know about what is network, how do we construct a network, which all network devices we have got, like what are routers, what are switches, then what is IP address, and then what is the OSI model or what is TCP IP model, how many different types of cables you have got. So all that basic information, like how many different topologies you can create probably in production environment. So that is all part of the network fundamentals. In fact, if you expand that, so you would be able to read all the topics that are part of this network fundamentals. So you could see that explain the role and function of the network components such as routers, the switches, that includes layer 2 and layer 3 switches both. Also, you would get to know that what is the meaning of next gen firewalls and IPS. What are the access points? And then controllers, like we have got Cisco DNA Center. Now Cisco has renamed it recently, and the DNA Center has been renamed as Catalyst Center. So Catalyst Center, so that has been renamed now, and the WLC is nothing but the wireless LAN controller. So if you are working on wireless network, then it is important for you to understand the WLC, because we control all the access points from WLC. Then what are the endpoints, such as your laptops, desktops, and what are the servers, and then what are the PoEs, power over Ethernet. So what is the meaning of that? Why do we require that? That's part of this section 1.1. Then in section 1.2, you have got the network topology architecture. So like how you should design your network. So you might go for 2-tier architecture. You might also go for the 3-tier architecture. Again, depends. You also have got the concept of pine and leaf, and then you have got WAN, like what is WAN, wide area network, and how many different types of WAN we have got. Then what is SOHO, small office, home office. And I don't know how many of you are doing work from home. So if you're doing work from home, then you should be aware of the home office. However, let's say if I'm working as an engineer and I'm not maintaining any higher post in the organization. So when I say higher post, which means I'm talking about the C-suite level of positions like CEOs, CTOs, CFOs. Ideally, they don't come to office every day. And as per their own thoughts and thinking, they says that they don't want to waste their time, so they start work from home every day. They have built their office at home, so that's called Soho. And ideally in that case, we also install a firewall, like they create a dedicated network at their home, and then they directly connect from their home to our corporate network. And that's how we call it Soho. It's not like utilizing remote access VPN and then doing work from home. And then probably you are using Palo Alto Global Protect remote access VPN or Cisco AnyConnect remote access VPN, and then you connect yourself to the corporate network and you start your work. So that's not Soho. I mean, that you can call it Soho as well, but the meaning of this Soho statement is to build the small office at home. Then you should be knowing that what is the difference between on-prem and cloud, because nowadays you can host your applications. So when I say applications, which means like Facebook, right? Facebook is an example of the application. You every day access the Facebook and you do the post, you watch the videos, and so. Facebook is an example of an application. Same is your Instagram, same is Twitter, and many more. So these applications can be hosted on-prem, which means that you can build your own data center and then you can install the application there. You can run application on your own devices. The second option is to use like AWS Cloud or Azure Cloud. I'm not sure if you have heard about that, but yes, there are many public cloud providers. So Amazon is one of them, AWS, right? Amazon Web Services. Then Microsoft is there, who is providing cloud services using Azure, Microsoft Azure. And then GCP is there, Google Cloud Platform. And there are many more. So you would understand that whether you should deploy your applications in cloud or you should build your own infrastructure that is called on-prem. So that's that. And then obviously you need to understand the physical interfaces available on your different devices. Like you have got routers, you have got switches, and every device comes with interfaces. Do you agree with that? Search for a router or maybe a switch over the internet. Cisco router images. Each router has got the interfaces. You see that? These are called interfaces over here. These are interfaces. So we will understand that how many different types of interfaces we have got, because ideally you would have Ethernet interfaces where you basically utilize the copper wire, but also you would have the interfaces where fiber cables would be needed or fiber ports will be there. And even within fiber, you have got two different types of cables that you might want to use, the multi-mode and single mode. That's what we will be learning about the cables. And then connections. like shared media, point to point. So the advantage of shared media is like you can interconnect more than two components. So that's the advantage of Ethernet shared media, like Ethernet switch. Ethernet switch is an example of the shared media. Like Ethernet switch comes with multiple interfaces, many interfaces. And let's say you have got 10 laptops and maybe printer, maybe scanner, maybe IP based cameras. You can interconnect or you can connect all those devices to a single device. That's your switch. Now all can talk to each other. Why? Because they are interconnected using a shared media. But if there are only two devices, let's say there is PC1, PC2, only two devices you have got that you want to interconnect, that's where you would use a point to point connection. So you would understand that what is the difference between shared media and point to point connectivity. Then you also have got the cable issues, like which type of issues you might get, what is collisions, what is errors, what is the mismatch duplex or mismatch of the speed. So we would identify or we would learn that how to perform troubleshooting when it comes to the physical layer. You also have the differences between TCP and UDP. You also get an option to learn about the IP addressing schema, the subnetting, private IPv4 addresses, public IPv4 addresses, and IPv6 addresses are there. And you have got the operating systems. So you should have some knowledge around the operating systems as well. Like on my laptop, I'm using Windows operating system. So in similar way, you must also use some operating system. You might use Microsoft Windows operating system on your laptops. You may want to use the Apple laptop, which would come with Mac OS. Sometimes you would see that machines are running with Linux operating system. And in few cases, it would be needed for you to have a machine installed with the Linux operating system or running with the Linux operating system. Because there are many operations that you can perform using Linux only. And the people working in cybersecurity, because most of you on this call have joined this training from cybersecurity background. So person who is from cybersecurity background must be aware that how important it is to learn about the Linux operating system. In cybersecurity, you do a lot of things using Linux. Then you also have got some basics of wireless principles, like what is wireless. So you should learn about non-overlapping Wi-Fi channels, SSIDs, radio frequencies, and of course encryption if it is supported there. Over here also we also talk about the virtualization fundamentals, like how do we perform the server virtualization. Like nowadays what we do is that we buy a big server, a giant server, maybe with 1 TB of memory, which is RAM, maybe 128 CPU core, or maybe more than that, maybe 256 CPU core, and maybe 100 TB of storage. So you bought one server, but then you can enable virtualization on that server. And on top of a single physical server, now you can install multiple virtual machines or virtual servers. So that's virtualization. So you would learn that how the virtualization works and how virtualization is important and useful in today's scenario. Also, you would learn about the containers, like what are the containers and VRFs. VRF is all about the network stuff, like usually create them onto your switches, Cisco switches and Cisco routers. And then you also have got some concepts around the Cisco switches, like what is MAC learning, aging, MAC switching, frame flooding, what is MAC address table. So these all topics you have got over here under section 1, which is network fundamentals. Once you cover the network fundamentals, then you would start with the network access. This is section 2. So first they are talking about the VLANs, how many different VLANs we have got, how to perform inter-VLAN routing if needed, what is trunking to interconnect switches. So for inter-switch connectivity, you would require trunk ports to be configured, and that's where you would require .1 queue and native VLAN. You also have got layer 2 discovery protocols such as CDP, LLDP. So you would learn about those protocols, their use cases, differences in between them, and the recommendations. And Ether channel is also there. Ether channel is nothing, but it is a way to bundle multiple physical links together into a single logical link. So let's say there are two switches interconnected using multiple links, and you want to increase the available bandwidth between the switches. You might want to use Ether channel for that. So that's where the Ether channel will come into the picture. You have got STP, RSTP. That's all about STP on your switches. And then you have got the wireless APs, AP mods that you can have. So basically, we will learn about the Cisco wireless architecture. You would learn that how to build a physical infrastructure using WLANs, wireless LAN. So APs will be there, WLCs will be there. You would require to configure access port, trunk ports, and maybe link aggregation. Link aggregation is nothing, but it is again kind of Ether channel. that you had before, like this. Then you would also learn that how to access devices using different protocols. And I believe that's being part of the cybersecurity team, you must be knowing about the telnet, ssh, https, ttps, TechX, radius. So you would understand that how to manage devices using these methods, different methods. So we'll cover those methods. Interpret the wireless LAN GUI configuration for client connectivity, such as WLAN creation. So I would explain you that how to create the wireless local area network, how to create SSIDs, and then how to apply the security settings, QoS profiles, and some advanced settings. So only interpretation is needed. Okay. Any questions so far? That's section 2. And then section 3 is there where your routing will get started. So you would learn that what are the routing protocol codes, what are the prefixes, what are network mask, what is next hop, what is AD value, what is metric, and what is the gateway of last resort. These are the terminologies that we use in routing. We will cover that, and that determine how a router makes a forwarding decision. Like, let's say packet has reached a router, a data packet, then how that router will make the decision to forward that packet. That's something that we need to discuss. Then static routing is there, and then OSPF routing protocol is there. So you have got only two different techniques to enable routing. One is static, the second dynamic, using OSPF routing protocol. So that's all you would get under section 3. Section 4 is about enabling some services like NAT, TP, DSCP, DNS, SNMP, configuring syslog, configuring DSCP client, and then configuring something around the quality of service. The quality of service is something which we use to improve the services that we are providing to our customers. Such as you are working in your office, and sometimes you might have to call your service desk saying that I'm unable to load anything over the internet. Like, I'm trying to access Facebook, but it's not loading. Maybe you are trying to access the official website of your organization, but still it's not working. And it is urgent for you to download some files from the email. Those email needs to be delivered with an attachment, but there are some issues that you are unable to download the files, larger file especially. Why? Do not have sufficient bandwidth. So now if you want to restrict, or if you want to assign the available bandwidth, more bandwidth to a specific user, is it doable? Yes. How? Using quality of service. So that's what we do. I mean, that's a basic idea that I gave you around the quality of service. Then obviously that how you can have your devices access remotely. Like, if you are sitting in India, but the devices are installed in United States, and I want to access those devices like routers, switches, firewalls here from India. How can I access them? Using SSH. Then we have got the capabilities and functions of TFTP and FTP in the network. So we got to learn that what is the use case of TFTP and FTP, these two protocols in our network. So ideally you would use this FTP or TFTP to transfer your files from one device to another device. That's the major use case of TFTP or FTP. So that's about the IP services. Then the next section is section 5, which is security fundamentals. And that's where you would learn more about security. So like, you would learn about the security concepts, like what is threat, what is vulnerability, what is exploit, what is mitigation, what are the mitigation techniques to avoid any threat or vulnerability or exploitation. And all of you, most of you are from cybersecurity background, most of you. So you should already be aware with these terminologies. So security program elements like user awareness is really needed. On-time training, I mean, time-to-time training for your corporate users. Then physical access control needs to be there. It's not like anyone can have access to your physical devices, especially routers, switches, firewalls. That should not be allowed. So physical security is also one of the important aspect when it comes to the security program. And device control, device access control using local passwords, and then security password policy elements. Might want to use multi-factor authentication, which is also known as MFA. You may want to use certificates for authentication or maybe biometrics. Then you also get to know that what is IPsec tunnel or site-to-site VPN to interconnect your two different remote sites over an internet. And the internet is always considered as a insecure channel or insecure transport. Now, over insecure transport, if you want to have a secure connectivity between remote sites, use IPsec tunnel between the remote site devices. So that's where you would use this feature. You have got access list, you have got DSCP snooping, dynamic ARP inspection. These are layer 2 security features that you might want to enable. Then you have to understand the AAA, which is authentication, authorization, and accounting, which is very, very important when it comes to the production environment. Everywhere you would see this AAA thing implemented in most cases, because you don't want to open your switch ports for everyone. What you want is that if anyone is trying to connect with the network, first they should authenticate themselves, and if they authenticated themselves successfully, then only network access should be given to those users. So this AAA is very important. And then of course you have got security features in wireless network also. So you would learn that how to enable security for wireless network. So that's about security fundamentals. And finally, this is section 6, which is around automation and programmability, where you would learn that how automation impacts the network management, compare traditional network with controller based networking, separation of control plane and data plane, northbound versus southbound API. You would get to know that what are the APIs and how we can basically utilize them. What are the advantages of having the northbound APIs or southbound APIs? What is AI? Generative and predictive artificial intelligence. I would explain you that what is AI, what is the use case of the AI, and what is generative AI and what is predictive AI. Okay, and machine learning in network operations, because now AI has already introduced in networking industry. So Cisco also wants you to understand the AI, artificial intelligence, and then the REST API. What is REST API and what is the use of it? Recognize the capabilities of configuration management mechanisms such as Ansible and Terraform. So I would explain you the use of Ansible as well as Terraform, right? Those are the templates basically that we use to deploy things quicker, faster, and automatically. Recognize the components of JSON encoded data. So ideally, you have to use some coding, right? Encode it, and I mean encoding. I'm talking about if you want to send data from one point to another point, so you have to agreed upon a standard encoding so that if sender is sending some data, receiver should also be able to understand that data in same format. Like for an example, if I start speaking in let's say in Kashmiri, in Dogri, or in Punjabi, probably none of you would be able to understand that. Similarly, if any of you starts speaking, let's say Tamil, or maybe Telugu, or Kannada, or maybe Malayalam, so I would not be able to understand you. But in networking, you can't do that. Like sender is using one encoding, data encoding, the other is the recipient is using something different, then there will not be any data exchange in between them. So they have to, like sender and a responder or receiver, they must agree upon one encoding mechanism. So JSON is one of the encoding mechanism that we use. So JSON is one of them, but you could also use the XML, and you could also use the YAML. So those are the different available options that you might choose from. But over here, we'll talk about the JSON only. So these are the total topics that you have got in CCNA, and this is called CCNA version 1.1. Earlier, it was just version 1, but now Cisco has came up with a fresh version called Cisco, CCNA version 1.1. So we will be covering now CCNA version 1.1. Any questions? Now remember that I don't think that I'll be covering all these topics in the same sequence which I have just described. Let's say I covered the routing first, and then I cover switching. Fine. I mean, it's okay. It's not a problem. After all, we should cover all the topics. And yes, some topics have got dependencies on other topics. So I'll make sure that first I cover the dependent topics. So the sequence might be adjusted by me, but after all, like once you cover this training, you would be able to understand all each and every topic that is listed here in this content or this topic list. Any questions from anyone? Thank you. And I'm back on this call now. If anybody has any questions so far, please do let me know. No? Okay. So let's get it started. I'll open up my PPTs now because I have already explained you like which all topics you are going to cover, so and so. Right, you got some ideas behind that. And the PPTs that I'll be using now are also available on your training portal. Let me open up the PPT quickly. Hold on. You should be able to see now. And let's try to make it interactive as much as possible, right? So I might ask questions to any of you in between, right? So you might have to unmute yourself, right? So let's start with the networking introduction. We are starting with networking introduction. What is network? So let me ask you, Arnab, first of all, what do you think by network? What it is all about? Can you explain the network?
So network is basically we can share our information with another person, uh, like information, like we want to send data, or we can connect a device. We can connect look a switch with a multiple end device like our computer. We want to browse.
Okay, anybody else?
Yes, myself. It's a process of transferring a data from one end to another end. It's a kind of the packets how it's transferred from one place to another through the routing switches.
Mm-hmm. Okay, anybody else?
So networking is a mode of communicating between
Exactly.
uh,
You're right.
devices.
Not devices. Forget about devices. Let's say I'm talking to
Between
you, Tamil, to
yeah,
you,
yeah.
Arnab, Hannah, Jithin, Noor, and Siri, Nishant, and then we have got Vishnu on the call. Now we all are connected through a platform. Using a platform, we all are connected to each other now. We all are talking to each other. What does this mean? That we are sharing our information between each other. If I'm speaking up, you all are listening. If anybody of you speaks up, then I also listen in. So we all are able to talk to each other. We all are able to share our information between each other, and this is called a network. But it is a human network. It is a human network. Now, network can be anywhere, right? So, obviously, we also have got this network in IT. IT, which means the information technology. So, a fully interconnected group of devices called network, right? Just like us. I gave you an example of the human network. So, even you have got your own network also, right? You have got a friend circle. Probably you might have created a WhatsApp group where you have added all of your friends, right? Your college friends, your school friends, or maybe your colleagues at your office, right? So wherever you have found your friends, you are creating a group, and then you all are talking to each other. So that's a network, because you are sharing some information between each other using some platform. So even in net IT, information technology, a fully interconnected group of devices is called a network, right? Networking is more than just connecting cables. Why? Because a lot of things can be done nowadays. Earlier, yes, you could say that if you interconnect the cables, fine, everything would work, whatever was needed. But at that point of time, we had limited functions, limited features that we turned on when it comes to the networking, right? In today's network, we have got so many things. Hmm? So networking is not just interconnecting devices using a cable, right? It has got lot many things than just connecting cables. Modern network carry different types of traffic having different requirements like voice, video, text, graphics. You know it very well. Like we all are talking to each other. So my voice traffic is also traveling through. I have also shared my screen. So video traffic is also going through. Or maybe I could have turned on my camera. So video traffic is also going through. The text, you're also browsing your internet, right? So when you browse the internet, you read articles, you read information over the internet. So that's a text traffic, right? Text data, graphics, you see pictures. We just saw that, right? So if you remember a couple of minutes back, I opened the switch and that was an image, right? The graphic image of the device, right? So even the graphics are getting traveled through the network. So you are accessing them. Now, what is internet? I just talk about the internet. I spoke about the internet. All right. So internet is nothing but it is a group of networks. And what is intranet? So basically, we need to understand those two terminologies now. First of all, let me ask you the question. Have you understood the network now? Like network is everywhere, like your cell phone, you are making a call, you are you are accessing internet over your cell phone. Even in today's scenario, your cars are also having the internet connectivity or network connectivity. Even people are driving from the remote locations. So the car has got network connectivity. We people, right, everywhere, like if you are going to bank, you are making transaction, again you need network connectivity for that. You're browsing internet, right? Again, you need network connectivity. So network is everywhere almost now in today's world, right? So for an example, if you go to a grocery shop, even they are, let's say you are buying something from there and then you are getting billed. So to generate the bill, they are also using some sort of application over there. So that application is accessible using some network. And even you are making payment through the UPI or whatever, again, network is needed. So even if you are going to buy some, let's say, vegetables or fruits, even the fruit seller or the vegetable seller, they are also using the UPI, that, a scanner, to receive the payments, and you are making the online payment. So now you go anywhere. I don't think that without network you would be able to survive in today's world. I mean, you can survive definitely, but it is very hard. You are doing work, you are doing job like in cybersecurity just because of the network, because things are interconnected and you need to protect them because all things are interconnected. All devices are interconnected, and if you want to protect your devices against the attackers, because if you create a network, then attackers will also be there. Like in in our society, the human society I'm talking about, if people are interconnected, then you would also see that one or two people will be anti-social element. So when I say anti-social element, which means that they can try to, they can have a fight with someone, or maybe they can try to, the thieves can try to steal something, some information, right? Whatever. So in similar way, when you interconnect things together using a network, it is also possible that one person who is also connected in your network can try to steal your information. So that's where the cybersecurity comes into the picture, to make sure that all your endpoints, all your machines, all your applications are secure against the attackers. Obviously, you cannot take the 100% guarantee that yes, your application is 100% secure. But again, the role of the cybersecurity team is to make sure that um, you know uh, your uh, your data is not stolen by the attackers easily. Okay, it's just like applying locks at home. So why do we lock our homes when going outside? So that we don't want to make it easier for anybody to get enter in our home and to steal something from the home. So that's why you use the lock. So it's kind of like that, right? So even the cybersecurity is playing kind of similar role in our day-to-day in our day-to-day life. So for an example, if you have got cameras and your cameras are connected to your wireless network, now you don't want any unknown person to access your camera streaming, right? So you need to protect your network against having the unauthorized access to your cameras, or maybe unauthorized access to your file server, unauthorized access to your print server or printers, right? So there are many things that you need to protect against the attackers, and that's where you need the cybersecurity. So if there is a network, then security has to be there. Well, we were talking about the internet and intranet. We need to understand those two terminologies as well. So first, let's talk about the internet. So it is a network of networks or a group of networks. Like for an example, I've got my laptop in my office, and then we have a small network. You guys also, from wherever you have joined this meeting, you are also having a small network, and then we all are connected to each other, and that's what makes it internet. Like obviously we are interconnected connected using a Zoom platform. So Zoom is also participating in our meeting over here, right? We are using Zoom as a platform, and that is the reason that we are interconnected. So you have got your own network, I have got my own network, even the Zoom has got its own network. And then there is someone who is helping us to interconnect all these people together, and that's your internet provider, like Tata, like Airtel. So Airtel has given us a cable at my office, Airtel has given a cable at your office or at your home, Airtel has also given one cable to the Zoom network. So everybody is interconnected through the Airtel, let's say, or Tata, or maybe BSNL, or maybe some other provider, right? But ultimately all providers are also interconnected to each other. So let's say you are connected to Tata and I'm connected to Airtel, which means that we can also talk to each other. That's the internet, because everybody is connected. So internet is nothing but it is a network of networks. So it's like this, right? So all countries have the let's not talk about from a country perspective. So when it comes to the internet, right? So there are internet providers, and I have just took their names, right? I took their names. Why? I mean, quite a seconds or quite few minutes back. Like Airtel is one of them. The BSNL is one of them, and then you have got Tata, you have got Idea, Vodafone, right? And there are many others as well. But some of them are called tier 1 providers or tier 1 networks. Then some of them are also known as tier 2 providers. And then, tier 3 providers. So ideally at home, let's say at home, I'm getting a connection, internet connection. So ideally we get it from tier 3 provider, tier 3 provider. But if you take an example of Tata, Tata is tier 1, Tata is tier 2, as well as Tata is tier 3 provider. And I believe that same applies to Airtel also. Okay, so using tier 1, basically the countries are interconnected. Using tier 2, then your cities are interconnected. And tier 3 is like within a city kind of thing. Okay, so it's like that. This is how you could segregate, or you could understand their meanings. Okay, so tier 1 networks are there, tier 1 providers are there who are responsible to interconnect different countries together. Then tier 2 providers are responsible to interconnect all your cities together, and then tier 3 is responsible to interconnect things within a city. So that's how you could see the internet is built. Then intranet is nothing but intranet is a network of a single organization. So let's say at I-MEDITA we have got our own network internally, and that's called intranet. So let's say I've got a printer, I've got a file server in my office, and then we have got some of the corporate users, and those corporate users are accessing the file server hosted internally, the print server hosted internally. Right. So this is an example of the intranet. Intranet is nothing but a internal network of a company, of an organization, is referred as intranet. So intranet is nothing but a network of the the internal network of any organization. Any questions for now?
No, it's clear. No.
What is networking? So per whatis.com, the networking in IT. Now let's talk about the IT networking, because as I told you that human networking is also there. Let's not talk about the human networking or any other type of networking. Let's talk about the IT, which is information technology. So in information technology, networking is a construction, design, and the use of network, including the physical, like cables, hubs, bridges, switches, routers, and so forth. The selection and use of telecommunication protocol and computer software for using and managing the network, and the establishment of operation policies and procedure related to the network. That's network. So it has got so many things, isn't networking has got a lot of things, like software is there, then your laptops, desktops is there, computer software is there, then telecommunication protocol is also needed, and then your network devices like hub, bridge, switch, router, maybe firewalls, and then cables are also needed to do the networking. So that's networking. So per the definition of networking is very simple. In information technology, networking is the construction, design, and the use of network, including the physical devices like cabling, or physical components like cabling, hubs, bridge, switch, router, firewall, and so forth. The selection and use of telecommunication protocol and computer software for using and managing the network. Okay, so that's networking. These all are the devices that we use in networking, in IT networking, information technology networking. So you see all of those devices right in front of, such as you have got desktop computer. And this is how you have joined this meeting. I'm not sure if you have joined this meeting using your cell phone also. I'm expecting that all of you have joined this meeting using your laptops or maybe desktops. So you have got desktop, you have got laptop, you have got a server. So I don't think so that you ever had a chance to have a server at home. But yeah, in offices, in your offices, you must have a server. Server is a place where you keep your information. So your data is in rest on your servers. So you use your servers to store your data, to store your information. So just for an example, on Facebook, you created your account. Not only you created an account, but also you are sharing some information. Maybe you are putting some notes, sharing videos or whatever, right? So your account detail must be stored somewhere. So where is that stored? So your information is stored somewhere on the server. So that's server. So servers are responsible to keep your data. So when I say data in rest, which means the data is being stored at server, okay, or on the server. IP phones, very, very useful. Especially you would see them a lot in call centers. So IP phones will be useful to make the calls. Nowadays, even IP phones, the hardware phones becoming less popular. Why? Because nowadays we are using soft fonts, like we are using Teams, Microsoft Teams, or you are using the Cisco WebEx, you are using Zoom, you're using GoTo meetings. There are many other solutions as well. So you don't require this IP phone nowadays a lot. The physical IP phone is really not needed. But yes, earlier we had a lot of IP phones in the organization so that people could talk to each other. So let's say you have got 100 branches. Now the people across all 100 branches, sometimes they want to talk to each other, right? So how would they talk to each other then? So that's where the IP phone came into the picture, right? So using IP phones, we enabled and the users to talk to each other. You have got lane switch. You have got lane switch. So it's a switch. It's a shared media actually. So if you have got like 10 laptops, 20 laptops, or 20 desktops, you want to interconnect all of them together. So to interconnect all your laptop or desktop computers with let's say you want to connect all of your laptops desktop with printer. So what we do is that we connect printer to this lane switch, and also we connect all your laptops desktops to this lane switch, because lane switch comes with so many different interfaces. A lot of interfaces will be available on lane switch that you could leverage to connect your devices with each other, right? So it's a kind of shared media, I would say. So it's a shared platform that would be leveraged to interconnect devices together, like desktops, laptops, servers, IP phones. Maybe you have got printers, you have got scanners, and all that. And firewall, as its name indicates, for security only. Firewall. Its name is like firewall. Why do we use firewalls when we go for any jungle safari? And let's say we are and then router, right? So firewall is for security only. And when you go for, as I was trying to take an example, like if you go and visit some, you go for a jungle safari and then you decided to stay within the jungle. So how do you protect yourself over there against any animals? I mean, what is the procedure that you follow there generally, any one of you? That's a firewall. Like you, what you do is like you will install your tent house first, right? And then you would just have to make sure that all around your tent house, you know, make a circle of fire so that no animals would be able to enter into your place, right? So to protect yourself against the animals, you use the firewall. And over here in information technology, in IT industry, we use firewall to protect our network against the attackers. The router. So as its name indicates, router, that would display or that would define the route. So it would help to take your data from one place to another place. So it does basically routing. So it takes your data, like obviously if it receives a data, and it will forward it towards its destination. So that's done by the routers. You might also have the wireless routers. Generally, you would work only on wired routers, but sometimes you may have to work on the wireless routers as well. But I never got an opportunity to work on the wireless router so far in my career. So it's very, I would say it's very difficult to see the wireless routers. Ideally, it is used by the telecom companies on their telecom towers, probably. I haven't used them, so I'll not make much more statements about the wireless router. But again, the function of wireless router is also same as the router. It's just that on wireless router, you don't have to connect your cables. So wireless. So it would have antennas, and using antennas, it will send and receive the data. Lane media is a cable, right? Then cloud. Cloud is nothing but kind of like AWS cloud or Azure cloud. So that's an example of the cloud. Wireless media, obviously you can use wireless media to send and receive data, but antennas must be installed. Like your laptop supports wireless, but it has got the wireless antenna on it, isn't? Tell me. Don't you think that your laptop has got the wireless antenna?
Yes, yes, it has. Like,
Yeah, I mean, all your laptops have got the wireless antenna to support the wireless, right? So that's using wireless media to receive and send data. And WAN media is also there. We'll talk about that later. It's not really needed as of now. Expectations from the network. So what is the expectation of the network? Tell me, any of you. Like, why do you build a network and which type of network you want to build actually? Let's say you are having the internet access at home. So how do you want to construct your network at home so that you always have seamless access to your internet?
There shouldn't be any disruption in between. Like
Anything else? Okay,
it
your
should
It
be.
should
network
be
must
secure and
be
we should be fast.
exactly. So let me tell you, the very first thing that we always make sure whenever we are defining or constructing a network, that it should be fault tolerant. Your network should be a fault tolerant network. So just in case if any of the router goes down, it doesn't mean that everything should go down. It isn't. So for an example, if you have, let's say you are traveling every day, right? You are going from home to office every day using your car, but you have got only one car, and that car, suddenly something happened and then car is not starting. It became faulty. Now, would it be possible for you to go to your office by your car? No. But what if you were having like two different cars? If one become faulty, then you can use the other car also. So that's how you make sure that at least one car is always available. But sometimes that can also happen that both cars are not available. Yeah, that can happen. So let's say if both of the routers goes down at same time, then what can you do? Nothing. But again, we should always try to design a network in such a way so that if any of the device goes down, like any one device goes down, then it should have some other way to reach the destination. Like it should not happen like if one goes down, then everything goes down. No, your network should be fault tolerant. Then scalability. The meaning of the scalability is that if you add more users tomorrow, let's say today I have got only 100 users in my organization, but tomorrow let's say we grow up and then we had let's say 200 users or maybe 300 or maybe 500, right? Does it mean that you would redefine your entire infrastructure now? Of course, you must not be doing that because that also includes the cost. So if you are redefining the entire network, you're replacing all your network equipments, then it is a problem. That's a wastage of money. So when you are designing a network, you're defining a network, you're constructing a new network, you should always keep the scalability in your mind. Like tomorrow, what if tomorrow you add 200 or 300 more users in this network? Would it be possible for this existing infra to accommodate that more number of users? If yes, good. So scalability is one of the major feature, right? Or not feature, I would say, is one of the major concern whenever you build a new infrastructure. So not only your infra should be fault tolerance, but also it should have the scalability. Components of communication. See, when you talk about the communication, what is communication? Can you explain me? Anyone on this call? What is communication? Tamil, can you explain me the communication? Like what is communication? I've already told you that what is communication. What is communication? Anybody on the call? Maybe Hannah. Exactly. That's the communication. So which means that one is sending some information, the other one is receiving. And that's how you exchange the information, right? One is sender, the other one is receiver. So you always gonna have a sender and then you will always have a receiver. Okay, so if sender is sending some sort of information, first of all it will have to draft that message and then it will have to encode on using a I would say you would encode your data using some, like I gave you that example also, like XML, YAML and all that kind of stuff. So you would have to encode your data and then transmit that using a signal, right? And then transmission medium could be your wireless, your wired, and then again receiver will receive that, will decode that data, and then once the data is decoded, your data will be displayed on the destination machine. Like if you access any website, so the server will send you some information, server will send some data, but before sending that data it will encode that. Once it is encoded, then it will be given to the transmitter will transmit the data using the media. Now, media could be wired or could be wireless. And within wired also, you have got two different options. Like you might have used copper wire. You could also use the fiber cable. So you could use any of the available option. So remember that when communication happens, one has to be sender, the other has to be receiver. Does that make sense? Communication will never happen without having the sender and the receiver. And you could see that in left side, the sender is like having servers and some other devices also, right? The receiver is your laptop or desktop. Ideally, this is what you do. Like you're using laptops, you're using desktop to access your applications. Like on my laptop, I might open the browser and then I would try to log in onto Facebook, Instagram, or Naukri.com, or LinkedIn, or Twitter, or whatever, wherever you want to log in. You log in it onto those applications using your browser, using your laptop. So if any information is given to you by Facebook server, then it is displayed on your laptop, on your browser. Now, network types. So when you define a network like intranet and internet, so now let's talk about the intranet, right? Obviously, it also includes like internet when we talk about the network types. But yeah, let's talk about the intranet, and that's your local area network. So when you talk about the network types, ideally you divide them into like local area network, wide area network, campus area network, metropolitan area network, or maybe small office, home office. So you can build your local area network, which is LAN. LAN is nothing. Let me just give you an example of the local area network. LAN is nothing, but it is a network within a building, let's say. Within a, tell me, building. Now, within building, you might have multiple floors. That's okay. The local area network is within the building, or maybe just within a floor. Within a floor, because a building, let's say in a building, there are many floors, and each floor belongs to a different organization. Then different organization will have different local area networks. But let's say all floors belongs to a same organization, then you can interconnect all those floors together. And that's why you call it LAN, local area network. So basically a network which is designed for a small geographical area is called local area network. Or you can simply call it a department of the organization. It is called local area network. Like for an example, if you speak about Tata, and Tata Motors especially. So within Tata Motors, they have got so many different departments, so many, like software development, and then they have got like HRs, right? Then they have got some IT team. They also have got their showroom owners. They also have got, let's say, the manufacturing units where they are manufacturing the cars, right? And also they might have some vendors also, the small vendors or suppliers, I would call them, like who are supplying the different parts to them, right? Who are supplying the different parts of the car. So they might also have the supplier. So they have to construct the network for each department, isn't? And that's something that you can call as local area network. Ideally, I would say that it is within a building. The wide area network is nothing but internet is an example of the wide area network, internet. Whereas in case of the local area network, it is an example of the intranet. It is an example of what? Intranet. Whereas the wide area network is an example of the internet, like a network which provides transmission of data between geographically distant location is called wide area network. And the best example of wide area network is an internet. And WAN connections are ideally provided by the service providers such as Airtel, BSNL. So those providers are responsible to give us the WAN connections. LAN we can build by our own, like we can buy laptops, desktops, we can buy printer, switch, and then we can also buy the cables, and then we can interconnect all or we can connect all the devices to the switch, and then all switches are all switches are also interconnected. So that's how you can build the local area network. But for WAN connectivity, obviously, since it is an example of the internet, so you would be depending upon one of the provider like BSNL, Tata, Airtel in India, and out of India, you might have to dependent over like AT&T, British Telecom, Orange Business Services, or Deutsche Telecom, or there are many other providers across the globe. Campus area network is within the campus, but you have multiple buildings. So let's take an example of a university. So within a university, it's a campus, it's a large campus, and then you get many buildings out there, right? And then each building is having multiple floors. Right? So that's called campus area network. Right? So that's not applicable only for university. It is also applicable for a hospital. Nowadays, obviously, for a hospital, it is also possible to have it is also possible to have a hospital using a single building. But if you take an example of the AIMS Delhi, there are many buildings out there, many different buildings. So they have got a campus where they have got multiple buildings, right? And then all buildings are connected to each other, and within building all the floors are also interconnected to each other, and that's called campus area network. So campus area network could be needed for a campus which has got multiple buildings, and the examples could be, let's say, you have got airports, you have got let's say hospitals, you have got universities, and even the IT companies like Infosys have got their campus here in Pune, and then Wipro has got their campus here in Pune. Now within the Wipro campus they have got so many different buildings, isn't? So that is also an example of the campus area network. Ideally we use the fiber cables, fiber optic, to interconnect all your buildings within a campus. Okay, it's a bigger version of the local area network. Yes, that is the correct step. The metropolitan area network, right? It's a network of a city, right? Of a city. Like for an example, within Pune, there are, like if you take an example of Tata, Tata has laid down two different rings across the Pune. So they have built this metropolitan area network. So within Pune, you have a man or metropolitan area network from Tata, but also you must have a network from Airtel, in my opinion. Like I know Tata has that, but I'm not sure if Airtel has got the dual fiber connections across the city. Usually they should have. Same applies to Geo. So, but this is within the city. Okay. And obviously local ISP is a good example for metropolitan area network. But ideally, in India, obviously we used to have local ISPs earlier, but nowadays the tier 1, 2, 3 all are same. Like if Tata is tier 1, they are also tier 2 and they are also tier 3 providers. So even the metropolitan area network is meant or is laid down by Tata or maybe by BSNL or maybe by the Geo or maybe by the Airtel. Soho. This is a small office network at home. That's called Soho. Always remember, it is a small office at home and it is ideally built for C-level officials within the organization like CEOs, CTOs, CFOs, and CEOs, customer operation officers, and like that. So only for C-level officers, you would see that we have the Soho small office home network. I mean, small office, home office. So you're building the office network at home. And then ideally you connect that home office to your infra using like IPsec tunnel or whatsoever. Maybe you're using SD-WAN or whatever you are using, but you are also connecting that office, that small home office network with the corporate network. So you do provide the connectivity between them. Okay. So network in a small enterprise and home where the number of users is less. Okay, that's where you create kind of Soho network. Data center. I don't know how many of you have heard about this terminology in past. I believe so. Everyone. I don't think that there is anybody who never heard about this keyword in past, like data center. So data center is something that consists a lot of servers. And not only servers, but also data center switches. Not only that, but also data center routers. Not only that, but also data center firewalls. You get all those network equipments. Ideally, when we talk about the data in rest, so data will be in rest at data centers only. So for an example, if you have created your account on Facebook, now Facebook must be having their own data center. So once you create your account over facebook.com, which means that Facebook is keeping some of your information because you created an account on their application. So Facebook must store that information somewhere in their own data center, right? So they have built their own data centers to keep your data. So that's the data center, and this data center is not applicable only for Facebook. In fact, all the service providers would have their own data centers, and then of course, like Facebook, these providers, right? Maybe Microsoft, Amazon, these all have got the data centers. Even the small customers would have their data center, whether it is hosted on-prem or it is hosted in cloud. It doesn't matter. But yes, data center is there, and this is how the data center is built out. You could see that, right? So we have got like the internet connection terminated on different devices, and we have got a firewall. We have got Nexus switches, and you could see that everywhere we have got redundancy. So if you see that one of the device goes down, one of the switch, one of the router, still there is no impact on end-to-end connectivity. So this is how you should build your data center. In data center, you use the interfaces of like 10 gig, even 40 gigs, And sometimes now, nowadays, even the devices are coming up to support or with the support of 100 gig interfaces. 100 gig I'm talking about. Okay. And you also get the copper wires, but in data center, we don't really prefer to use the copper wires when it comes to the cables. We prefer to use the fiber optic cables. Okay, so data center is a facility used to house computer system and associated component. It generally includes redundant backup power supplies, redundant data communication connections, and various security devices. That was data center. So everywhere you would find redundancy in data centers. Why? Because you cannot risk in your data center. Let's say that Facebook data center goes down, then across the world, nobody would be able to access the Facebook. That's a problem. So, like in data center, the redundancy is very, very, very critical. Communication needs rules. Of course. Of course. Communication needs rules. Like for an example, let's forget about the information technology communication, IT communication. Let's talk about our communication, like between me and you. Let's say if I allow you all to unmute yourself and to speak up whenever needed, there can be a problem like overlapping of talking, like we are talking all together. Nobody is understandable now. So rules have to be there. So if I'm speaking up, if I'm talking, then nobody else should talk. And if somebody is asking question, then only one person should ask question at one time, isn't? So rules have to be there for a better communication. So if communication is happening in information technology, in IT, infra, then rules have to be there. Okay. And rules for any type of communication is called, tell me, protocols. Like we have constitution. The constitution is there just which tells us that how we should live in this country, that defines the rules and regulations, right? So that's what the communication need. So communication needs rules and regulations even in information technology, and that's called the protocol. So protocol would help to define rules and regulations for any communication happening in information technology. So when you talk about the human communication component, like sender is there, receiver is there, the method of communicating, common language and grammar is necessary. Like if we are not using common language, like I'm speaking, as I gave you an example in past also, today itself, right? I gave you that example. Like if I speak in a language which is not understandable by any of you, then would it be really useful for you to attend this lecture? Of course, no. You would not be able to understand anything. And even on top of that, let's say if I'm using the same language, but you're not able to understand that because the grammar that I'm using is completely different. So it's very important for us to have a common language in the grammar. Speed and timing also matters a lot. If I start talking very fast and you're not able to understand them, obviously that's very important, right? The speed is very important. The timing is also important. The confirmation, it depends if I require the confirmation or not. Like sometimes I'll go back to you and I'll ask, hey, Arnab, have you understood things? Hey, Hannah, have you understood things? And then you would unmute yourself. You would say, yes, we have understood. So sometimes I'll ask, sometimes I'll not ask. So it will be depending upon topic to topic, right? So for few topics, yes, I would ask you, hey, can you confirm if you have understood this or not? So I'll ask for the confirmation, but sometimes I will also not ask for the confirmation. So that depends. And that's for human communication. Now in IT, information technology, we have got protocols. Some protocols are proprietary and some protocols are standard. So the meaning of proprietary is like those are developed by a specific vendor, right? And can be used by that vendor only. Like if there is a protocol developed by Dell, then only Dell can use that. So that's called proprietary. Or maybe there is a protocol developed by Cisco, then Cisco devices can only utilize that protocol. That's called proprietary. If Cisco can only utilize that protocol, and standard is something that anyone can use it. I'll give you an example of the standard protocol, like HTTP. Everybody can use HTTP to access the websites. So that's the standard protocol. DHCP, anyone, all supports DHCP, like whether it's Linux, Microsoft Windows operating system, or the iOS from Apple, they do support DHCP. So that's the standard protocol. DNS, everybody supports DNS. So that's the standard protocol. So some of the protocols are proprietary and some of them are standard. So the proprietary, earlier we had more and more protocols as proprietary, but now, whenever any vendor is designing a protocol, ideally they try to make it standard protocol. So you have got, when it comes to the standard, which means that you have got IEEE standard, then IETF standards. So under IEEE standard, you get like technologies such as 802.11a11b, that's for wireless network, or 802.1q, that is for tagging. But IETF standard is like you get your protocols over there, like IP, Internet Protocol, right? IP is a protocol itself. TCP is also a protocol itself. HTTP is a protocol itself. FTP is a protocol itself. So these all are the protocols. Any questions so far?
No, it's clear.
Fine. So I think for today, let's keep it here. Probably tomorrow, some more people might join in. So I don't want too much of wastage of their content, right? That they are joining this class. If they join this class, right? From tomorrow. So I hope that you also have got an idea that what all things you need to go through, right? So I'm just covering the basics of network, and I know that each one of you have got better understanding of the basics of the network, but still I'll cover each and every basic aspect of the network. Wherever you feel that you have got some questions, do not hesitate to ask them. Let me tell you very much clearly, any point of time whenever you feel that you have a doubt, do not hesitate to unmute yourself. See, don't make this class as a passive class. Try to make it interactive as much as possible. Make it
Yes,
interactive as much as possible. And you can
yes.
make it interactive by asking the questions only. Yes, tell me.
Excuse me. Here in my company, we are using this Avaya switches. What kind of
Okay.
difference is make from Cisco and this Avaya about this
See,
coding?
these two are two different OEMs. So the major difference would be of command syntax. Rest will remain same. Like if you talk about the switches, the VLAN has to be created there, the trunking has to be configured, or maybe inter-VLAN routing needs to be configured. So everything will be supported by a via switch also, but the only difference would be the command syntax because operating system has got changed. So let's say if you are working on Microsoft Windows operating system, and then if I give you a laptop from Apple and then you have got iOS, so obviously the options will be different, isn't? And if I install the Red Hat on one of the laptop and I give it to you, then the options will be different, isn't? So similarly, it applies to Avaya and Cisco. So both have got switches there. You can configure their switches, but the command syntax will be different.
I mean the CLI command line interface.
Exactly. But mostly features are same. Mostly. I mean, obviously, all vendors, all OEMs have got their pros and cons at same time. But mostly technologies are same.
Yes, yes. So if I complete this course, it will I can work on Avaya switches also, right?
I will teach you Cisco switches, sir. This
No,
is
no, I
CCNA,
understood
Cisco
that, but
certified.
see,
Yeah, I got it. The
yeah.
only thing that you can do on Avaya, I will not teach you anything about the Avaya, okay? But
Okay.
since you would understand the concepts of Cisco switching, which means now you can Google the information for Avaya switches, correct? So that's how it would be easier for you to work on the Avaya switches. But I want to make clear this thing very well that we are not going to work on the Avaya switches here during this training.
I
Cisco is
understand.
different
Okay.
vendor and Avaya is a different vendor. Avaya has got their own certifications as well. Cool. So, and Avaya has also become bankrupt, I believe. So they declared the bankruptcy last year. I'm not sure what's happening with Avaya. They had most of their business from VoIP, and VoIP is shrinking nowadays. Many problems for the Avaya going forward. Basics of the CCNA, like what all things we are going to cover during this training. Apart from that, we also had a discussion around some couple of more things, especially like what is network, what is internet, and then like what is intranet and so forth. And we are going to proceed further with the same topics. If anybody has questions, any questions from yesterday's session, go ahead and ask those questions. No? Okay, good. Let me open up the PPTs and then we'll proceed further. Tamil, I think you have joined from two different machines. Can you please log out from one machine? Okay, it's gone now. So, yeah, wide area network. This is what we discussed yesterday, right? So let's go ahead and then let's talk about the campus area network. This is also something that we already discussed about, and the metropolitan area network and the SOHO. And of course, we then spoke about the data center. Then communication. This is exactly what we were discussing yesterday. This is where we laughed that, okay, communication needs certain rules that you should follow, certain rules to perform or to do the communication. So communication would definitely require some rules for, to be applied so that we can have the communication in place effectively or in a more efficient way. And yeah, to do so, rules has to be there, right? So we have to apply certain rules to achieve that. So when you talk about the rules is rules makes a protocol. So protocol is a set of rules basically. What is protocol? It is a set of, and the protocol can be either proprietary or standard. So as I told you even yesterday that the proprietary protocols are developed by any specific vendor, such as maybe Cisco or maybe Avaya or maybe from HP, or they are developed by maybe Microsoft or Red Hat and so on and forth. There will be some vendor specific protocols, and those are known as proprietary protocols. And then you have got the standard protocol, also known as the open source protocol, and that can be used by any vendor. And I gave you a couple of examples of the open source or standard protocols, right? So for standard protocols, like you have got HTTP, you have got TCP, you have got UDP, you have got DNS, you have got DSCP. These all are the standard protocols, which means can be supported by anyone. Those protocols, their source code is openly available for anyone. So even you, if you are developing your own operating system, you're developing your own machine, fine, you can go ahead and you can use the same source code and you can modify that a little so that your operating system, your machine can support that protocol. So the meaning of the standard protocol is like anyone can use them, their source code is openly available. The proprietary is like let's say there is a protocol, something like CDP, Cisco Discovery Protocol. So that's protocol that you would learn in future, but CDP is a proprietary protocol that was developed by Cisco for their own devices, right? So CDP runs only on Cisco devices. That's why you call it proprietary protocol. So there are a lot of proprietary protocols, there are a lot of standard protocol, but generally in networking we mainly discuss about the standard protocol, or you would learn mainly about the standard protocols. As I told you earlier, we had more and more protocols as proprietary protocol, but then later they made them the standard protocols. Like I can give you many examples where Cisco developed a protocol, but then later Cisco made them standard protocol, and then it became available for everyone to use. So like I can give you an example of the MPLS technology. So there is a technology in networking called MPLS, multi-protocol label switching. So in beginning that was developed by Cisco, but then Cisco made it available for everyone. So that's one example, and there are many other protocols. Those were developed by a specific by a specific vendor, but then later on they made that protocol available for everyone, and that's how the protocol became the standard. So standard is that protocol which is available for everyone, right? Anyone can use them. Now when you talk about the standard protocol, so ideally there are two different types of standards that we follow: IEEE and IETF standard. So some protocols will fall under IETF, and some technologies would fall under IEEE standard. If it is about the protocols, ideally protocols would fall under the IETF standard, whereas the technologies like your wireless technology, dot 11, 802.11. So it's a technology, it's not a protocol, right? So it's IEEE standard, right? It has got what? IEEE standard. So 802.11 is the IEEE standard number. Whereas in case of the IETF standards, the protocols would be there, and then for each protocol, you would have RFCs. RFC is nothing but a documentation of that protocol. RFC is nothing but, in short, it is a documentation of that protocol, and RFC stands for like request for comments, right? So each standard protocol would have a RFC number, which means that it comes under IETF. You can also, like for an example, if you go and you Google the information around the IETF or IEEE, you can easily get the information around that. Okay. So the technologies like .11, which is a wireless technology, falls under IEEE standard, whereas the protocols like open source protocols, the standard protocols, falls under the IETF. So IEEE stands for international. I mean, you can. I can't really recall that, but yes, you can simply Google the information around knowing the full form of IETF and IEEE. So you can easily search about them. That should not be a big issue or big challenge. Well, so you just came across that some technologies earlier, mostly we had the vendor specific technologies like proprietary. More and more technologies were proprietary because no one wanted to share their business secrets. It was a business secret, right? In the beginning of the internet. Just imagine, we are talking today, but internet started around 1970s, around 1970s. So at that point of time, if any vendor, if any company developed a protocol or a technology, so obviously they were not sharing the information around that technology with anyone to make the business out of that. So in beginning, you would see that a lot of proprietary protocols and technologies were there. In fact, like different operating systems will use the different protocols and different standards were there, and then later OSI model came into the picture. I don't know how many of you are already aware with the TCP/IP model or OSI model. The objective behind introducing TCP/IP model or maybe OSI model was to have a standard kind of documentation that we could refer to understand the traffic flow, or the protocols could be developed. In beginning of the internet, even that standard was not I mean, that standard never exists. So all vendors had their own, like Apple Talk was there, and then Microsoft had something different, and some other vendors had some different mechanism, right? They all had different methods. So it was very difficult to develop a technology. Now, whether you would develop a technology that would be supported by Microsoft devices only, or maybe some other operating system. So I mean, it was very difficult to take the decision. So then later people started making their technologies available for everyone, which means that those technologies started become standard technology. That's that. I hope that everybody now has an idea about the protocols. So protocol is nothing but it is a set of rules, right? So whenever protocols are developed, those can be either proprietary or standard, which means that it's available for everyone. The meaning of a standard protocol is that protocol is basically available for everyone. That's the standard protocol. Anyone can use them. Like I gave you an example of DNS. Like if you are using an Linux operating system, still you can use DNS, the same protocol. Or if you are using Microsoft Windows, still you can use DNS or maybe DHCP. So those protocols are mainly supported by everyone, and that is the reason that we call them standard protocols. But then you can also have the proprietary protocols. Okay, I mean, those were also developed. So as I gave you an example, that in the beginning of the internet world, mostly vendors or mostly OEMs or mostly organizations, companies were developing only proprietary protocols at that point of time. But then, yeah, later, nowadays, the standard protocols are more famous. Why? Because if you are developing a standard protocol, which means that it can be opted, or it can be accepted by all of the OEMs, by all of the organizations, if it is very useful. So if you are developing a protocol, and if you see and if you think that it is very very useful for everyone, then make it standard so that anyone can use that protocol. Now, there are many protocols for many different reasons, or I would call it for many different purposes. Can you give me a sec, please? I'll be back in a moment. Just give me a sec. So again, you can also compare the protocol by making an accessories. So for an example, if you are making an accessory for cars, I'm giving you an example, right? A general example. And the accessory that you developed can be used only by Toyota cars. Any other manufacturer can't use your accessory that you developed. Now, just imagine if you would have developed an accessory that can be leveraged or that can be utilized not only by Toyota but any car maker across the world. So, don't you think that in that case, your the sale of your accessory would be higher than if it was sold only for the Toyota? Don't you think? So that's an advantage that you get if you come up with a standard protocol, that more and more people can use that protocol, can utilize that. That's that. Well, now we have got different protocols. Like if we talk about the constitution, let's talk about the Indian constitution, right? You know that we have our own constitution, and that tells us that how we should live, how we should behave, and all that. Like a lot of rules and regulations are there that we should follow as a citizen of India, right? And that constitution is built by leveraging many, many, many articles. And what is an article? Article is a set of rule, right? So again, an article can also be called as a protocol. right? So we have got so many protocols in our constitution. In similar way, if you talk about the network, the IT network, right? IT networking or information technology networking, we have got so many different protocols for different purposes. So point is that basically we have divided the whole process. Like if you are sending your data from your laptop to another laptop, let's say, or if you are accessing Facebook, you are accessing an internet. So that whole process is broken into multiple, that process is broken into multiple steps, and those steps are also known as layers. And for different steps or for different layers, we have got different protocols. So basically, in this whole communication thing, like whenever we talk about the communication in information technology, in IT, when you talk about the communication, then there always has to be multiple layers and multiple protocols. Do you all get it? Hello.
Yes, sir.
Yes, yeah, we can. Yeah, we
Good,
hear it. Yes.
good, good, good. So, I mean, if you are following me, then just do let me know, acknowledge that, right? If you are following. So, what I'm saying is that whenever communication happens between two devices, right, in information technology, then it will include multiple layers and multiple protocols to achieve that. So, let's say if you are talking over a phone, or maybe you're talking to me over the Zoom platform using an internet. Again, we are talking by leveraging or by utilizing multiple layers and multiple protocols. Okay, so that's what we are using. So basically, in information technology networking, in IT networking, we have got multiple protocols and multiple layers, and each layer would have its set of protocols, right? Each layer would have a set of protocol. So you could see that each layer is having a set of protocols. Obviously, in future, when when we deep dive more into the TCP/IP model or OSI model, right? When we discuss in more details about these layers, and then I will explain you that how things are happening and which all protocols are working at which layer of the OSI model. But if you take an example over here, so we have got, as I mentioned, we have got multiple layers to perform this process, and then we have got multiple protocols working at different layer of the OSI model. And some of the well-known layers are like application layer. Like at application layer, you get your data. Then you have got the transport layer, which is also known as layer 4. Then this layer 3 is also known as network layer, and this layer 2 is also known as data link layer. So basically, we have got different layers, right? So this communication is happening through these different layers. So if sender, let's take an example of the sender, right? Sender will send some data. So ideally data is created at application layer. Data is created at application layer. Let's say you want to send some data. So that's the application layer. That is the application layer. So at your application layer, you have got your data. Now let's say you wanted to send this data. So if you want to send the data, then from application layer, data will be given to the transport layer. At transport, some header or some extra information will be attached on top of it, such as TCP header. This is just an example. So basically at layer 4, we are utilizing TCP. TCP is nothing but it is a protocol, transmission control protocol. And at application, we used, let's say, HTTP. HTTP is nothing but it is a protocol that works at layer 7 of the OSI model. So if you have got some data at layer 7 and that is encapsulated by HTTP, and then it is given to the transport layer, and at transport layer, since TCP is working, now remember that it is also not mandatory that you would use only TCP at transport layer. You could also use UDP, and there are some other protocols as well. But we are assuming here that we are leveraging TCP, therefore TCP would be responsible to encapsulate your entire data. At network layer, again, we have got multiple protocols, but IP is one of them. IP is nothing but it is an internet protocol, right? So IP will encapsulate your data that it got from the transport layer, right? So now IP is encapsulating your entire data, and then IP header will be attached on top of it. And IP header would contain the source IP address and destination IP address. Now, I'm sure that some of you are already aware with an IP address, and probably some of you are not really aware with the IP address, which is okay. I'll explain that in more details later. And then data will be given by network layer to the data link layer, right? So at data link layer, the frame header will be attached, or Ethernet header, I would call it. So if you are using Ethernet technology, then Ethernet header will be attached on it. And if you are using some other technology like frame relay, then frame relay header will be attached on that. But again, once data is given to layer 2, one more header or the encapsulation will take place one more time. And then finally, your data will be placed onto physical media. So you could see here that you had a data which was encapsulated by the application layer header like HTTP header, and then TCP header was attached, then IP header was attached, and then at layer 2, not only you attach the header but also you attach the trailer. So you got the header and trailer both at data link. When sender is sending some data, the encapsulation will take place. What will take place? Encapsulation. Remember, if you are learning your data transmission, or if you are learning the process of data transmission from the sender point of view, then at the end of sender, the encapsulation will always take place. So the data will get started from the application layer, then it is given to the transport, then network, then data link layer, and at each and every layer, some extra information will append on your data, and that's called header, right? And that is also known as encapsulation, right? So every layer, like from a sender point of view, each and every layer is attaching some extra information onto your data, and that's called encapsulation. It is very simple to understand from one example. Like I would like to give you one example. So let's say you had a data. Let's say you wanted to courier one letter. You wanted to courier some, one letter to me. So if you are doing that, obviously you will have to draft that letter first, and that's your data. And then what you do is that you put that letter in an envelope, right? And that's kind of like layer 4, right? You have put that into one envelope. Then probably if it was really critical, you would put it in one another box, and on that box you would also specify your source and the sender and receiver's address, right? And once you put that, you would probably give it to your postman, and then postman would see, okay, this letter or this box is is getting shipped to Mumbai or to Pune, and then it will be placed into the same box where all the data is going to Pune, right? So again, this is called encapsulation. So when you are adding some information onto your data, right? So this is called encapsulation. And remember that sender will always perform the encapsulation. Sender will have to draft the data, and then at each layer, some extra information will be added on your top of data. And that's something that we will learn in more details. So encapsulation and decapsulation is very simple. Like if you are if you order something from Amazon or maybe from Flipkart, right? So the sender will always perform the encapsulation. They will collect, or let's say you ordered something from Flipkart, the seller would pick the object that you have purchased, right? And then will place that object into a box, and then maybe that box will be placed in another box, and then that box will be delivered at your door. And then once you receive that, then after you open up that box, and maybe another box was inside the bigger box, right? A small box was there, and then you would open up that small box. So that's called decapsulation, isn't? So when you add something, that's called encapsulation. When you detach something or you remove something, that's called decapsulation. So remember that sender, right, will always perform what? Encapsulation. And the receiver will always perform what? Decapsulation. So have you all understood this mechanism? Hannah, you joined late, I believe so.
Yes, there was some network
Oh,
issue.
okay, got it. But have you understood this explanation that I just gave here?
Yeah, got it.
So
And
every layer, from a sender's point of view, some information will be added onto your data, and that's called encapsulation. Whereas from the receiver's standpoint, the receivers will always remove some sort of information post receiving the data, and that's called a decapsulation, right? So always remember, in information technology networking, in IT networking, the sender will always be performing encapsulation, whereas receiver will always perform the decapsulation. So just take an example from this user. Let's say this user wanted to send some data. Wanted to some wanted to send some data, right? So this is encapsulation. So it starts with your application layer. So at application layer, you have got the data, and then it is given to the transport layer, and then transport layer header will attach on it, and then it is given to the network layer, and then at network layer also the header will be attached on top of your data. So now there are two headers. One is transport layer header and the network layer header, and then further it is given to the data link layer, and that's where the header and trailer both are attached onto your data, and then after your data will be placed onto your physical media, which is your wire. Using wire, it will be received by, let's say, by the receiver, and probably that's your server who is receiving that information. So first server will receive that data in form of bits, right, using this wire, and then it will convert that into a frame, and then it will remove the frame header and trailer both, and then it will give it to the network layer. I'm talking from a receiver recipient standpoint, right? So always remember that encapsulation will be performed by the sender, whereas the receiver is always going to perform. So this is sender. But then once data is received by the receiver like this, so it receives data in the form of bits first as part of this cable. So using this cable, it will receive your data in the form of bits, and then it will convert that bits into the frame, and then header and trailer of that frame will be removed, and then it will be given to the network layer. At network layer, the network header will be removed, and then it will be given to the transport layer. At transport layer, the transport header will be removed, and then it will be given to the application layer. So that's how the data gets delivered. So you could see that the sender always added some information, right? And that was encapsulation. Whereas the receiver is receiving some data, and then you could see that that receiver is performing decapsulation layer by layer. But remember, this whole process would happen in a sequence, right? So you cannot override, or you cannot change the sequence of encapsulation and the decapsulation of the data. So that would always be your sequence. The sender will always perform encapsulation, whereas the receiver will always perform decapsulation. Now, remember that to understand your data, right, that how your data is going from your laptop onto the physical media and how it is being received, or maybe if you are using a wireless media or you are using fiber optic cable, still you have to learn this binary maths, binary method. So ideally, any calculator or in information technology, your data is transmitted in the form of binary only, where you use the bits like 0 or 1. So we are always using binary number system to send the data and to receive the data. So and then decimal number system. So you know that we have got multiple number systems, like binary number system is one of them. But then we also have got the decimal number system, and this is what we use in our daily life. In our daily life, we are always using this decimal number system. And you know that in decimal number system, we have got the numbers from 0 through 9, like 0 1 2 3 4 5 6 8 9 6 8 6 6 7 8 9. So these all are the numbers that we are using in the decimal number system. So you can use any number between 0 through 9, and that's what we use every day. Like, okay, give me 90 rupees or 1000 rupees or 2000 rupees or 1500 rupees or 1545 rupees or 9 rupees or 8 rupees. So in our day-to-day life, we are using decimal number system. But then computers don't use decimal number system. Computers use the binary number system. Like, the data is always transmitted in the form of zeros and ones. Okay. So remember that if we have got so many different number systems, right? And yeah, binary is one of them. But then you also have got the decimal number system and then hexadecimal number system. So there are many different number systems out there in mathematics. So there are many number systems, number system rules. But again, remember that every number system starts with 0, like binary starts with 0, goes up to 1. In binary number system, we have got only 2 digits, 0 and 1. Whereas in decimal number system, we have got 10 digits from 0 through 9. Okay. And then you have got a hexadecimal number system where you have got 16 digit from 0 through 15. Ideally 0 through 9, and then A to F, A, B, C, D, E, F, like that. And that's the hexadecimal number system. So in hexadecimal number system, you do not have only numbers, but also you have got alphabets. But in decimal, you have got only numbers from 0 through 9. And in binary, also you have got only numbers from 0 to 1. Okay. So remember that every number system is starting with 0. Okay. That's something that you should always keep in your mind. Right. So that's that. Binary to decimal conversion and back from decimal to binary is very important for you to understand, because obviously your laptop, desktop, or a server will do that automatically. You don't need that. But thing is that you should be knowing it, right? You should know that how to convert or how to translate decimal into binary, and of course vice versa. Okay, so it's very easy. Okay, this is the formula that you should always keep in your in your mind, like 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 3, 4, 5, 6, 7, and you can keep going. 2 raised to the power 8, 2 raised to the power 9, 2 raised to the power 10, 11, 12, and so on, right? But then 2 raised to the power 0 is 1 basically in decimal, and then 2 raised to the power 1 is 2, then 4, then 8. So basically you just have to remember this formula, and this formula can be used to translate your binary into decimal and vice versa, right? From decimal to binary. So you can use the same formula to translate your binary number system into decimal, and again from decimal back to binary. The same formula can be used, but it will be used at the time of IP addressing and subnetting, not before that. Okay. But yes, you should be knowing the conversion between binary and decimal number system. That is important. Later we will learn about the subnetting and all that. Binary versus decimal versus hexadecimal, right? So you could see that over here, this is decimal number system, this is binary, and this is hexadecimal. So in hexadecimal, if it is 0, in binary, you would represent it by 4 zeros, whereas in decimal, you would call it 0 again. In decimal, if it is 1, then in binary, it will be 0001, whereas in hexadecimal, again, it will be 1. But if you look at the 10, 10 is like 10 in decimal, but then in binary it's like 1010, and then in hexadecimal it is a. So these are the binary and their respective or their opposite decimal, and their respective decimal and hexadecimal numbers are also given over there, over here in this table. So it's easy to represent a digit in hexadecimal. It takes like minimum 4 digits. So we will learn more about this conversion, but let me give you, let me give you an example of converting binary into decimal and then from decimal back to binary, right? So let's say you had a 65 into decimal, and now you need to convert this into binary. So this base 10, which means that this is a decimal number system, because it could also be hexadecimal number, right? But it is a decimal number system, which is 65. It has base 10, and then you have got base 2, which is your binary. So you have to convert your decimal number system into binary, and it's easy. You have a formula, as I told you: 1, 2, 4, 8, 16, 32, 64, 128, and so on. You need to pick only those numbers by adding which you can get 65. Okay. So now 128, you can't pick that up because that's more than 65. 64, yes, you can pick that up. So whenever you pick a number, just make it 1. Right underneath that number, just make it 1. 32, it's higher. If you add 32 into 64, it will exceed 65. 16, it will also exceed. 8, it will exceed. So don't pick that up. So make it 0. Make it 0. Again 0. But 1, yes. So this is your binary number system: 1000001. That's how you would convert your decimal number into binary. I can give you one more example. So I'll keep this formula as it is: 1, 2, 4, 8, 16, 32, 64, 128, and you can keep going. So last time I took 65. Let's pick maybe 127. So 128 is higher than 127. So don't pick that up. So let's make it 0. Then 64. Yes, you can pick that up. Then 32. It makes 96. So you can pick this up. 96 plus 16. That makes 1. Tell me, 64 plus 32 is 96. 96 plus 16, 112. So you can also pick that up. 112 plus 8, that's 120. Then 124, 126, and then 127. So basically in binary, it will be like 0, 1, 1, 1, 1, 1, 1, like this. So this is your binary number system. So you translated 127 that was in decimal into binary using the same formula. Now I can use same formula to translate the binary into decimal also. So let's say I had 10101010. This is binary. I have to convert it into decimal. So again, put the same formula: 1, 2, 4, 8, 16, 32, 64, 128, and maybe you can keep going. But how many digits you got? Just 8. Put all the numbers under each number, like starting from right. So 0, 1, 0, 1, 0, 1, 0, 1. Now add all those numbers which are containing ones. So that's 128 plus 32 plus 8 plus 2. So 128 plus 32, this is 160, then 8, 168 plus 2 is 170. So basically it would be 170 in decimals. Okay. So I used the same formula for translating binary into decimal and vice versa. So that's that. Well, we'll learn about that in more details once we start with IP addressing and then subnetting also. But for now, let's focus on OSI model and TCP IP model. This is again very important to understand the traffic flow. Okay, because our primary objective would be to understand that how traffic is being sent from our laptop, how it is going through the server. So that is really important for us to understand. And to understand that, we have got this OSI model or TCP IP model. So obviously OSI came first. OSI came first. OSI model came first, where we had these 7 layers. So this whole process of sending data, let's say you had a laptop, and to put your data from laptop onto your physical media, maybe wired or wireless, we had these 7 steps, or you call them 7 layers as per the OSI model. Whereas in TCP IP model, we had only 4 layers. So that's a major difference. Nowadays, we use only TCP IP model. In fact, I can, I can prove that. So let's open the ncpa.cpl. So there is a command that I use. Guys, I'll show you here, right? I also have to teach you the basics of the operating system. So this is a wireless network, and I'll go to properties here. And then if you look at the TCP IP, do you see any OSI model over here? No, I don't see that option at all, but I see TCP IP. That's what I said, that we use TCP IP, but you would not ideally see the OSI model anymore. First OSI came, and then TCP IP model was launched. And we had some background of the TCP IP model also, and that was the DoD model. So first DoD model came, and then after this TCP IP model came into the picture. Okay. Well, we will have to understand both models, the OSI model, its pros and cons, and then again we will have to understand the TCP IP model, because again TCP IP model would help us to understand that how traffic is moving between the endpoints. And it is really important for us, being a network engineer, it is very important for us to understand that how traffic is moving between the devices. I told you that before even we proceed further with OSI model, I would like you to understand some basic function of your operating system itself. So to do so, I'll do one thing. Just hold on. I'll minimize the PPTs, and I'll give you, or I'll teach you a couple of things here. So this is Windows operating system, right? And we must be knowing about it, some basic stuff. Okay. That's really important for us to understand all that basic stuff over here. You can always go to command prompt. So there is a search box. Just type CMD, which is command prompt. You can open up this command prompt. Once you open this command prompt, there are some basic stuff that you should be knowing, such as if you want to know that you can ping Google or not. So there is a command called ping. It's a ping command. We can always use this command to test, to see if we have got connectivity with some remote facebook.com or remote application, facebook.com or twitter.com, whatsoever it is. So let's say google.com. So ping google.com, and you see that we are getting the replies back. You see that? We got reply. So it says that, hey, we tried to ping this name, but then that name got translated into an IP address automatically. And mainly this work is done by the DNS. There is a protocol called DNS, domain name server, or domain name system. So that is responsible, or that protocol is responsible to change or to translate, basically, not change, I would call it translation. So it will translate your name into an IP address. And this is what exactly we have got here. That's one thing. Second, that's ping command. The next command that you could use on your command prompt is tracert. Tracert -d. -d, I'm putting that to disable the name resolution. To disable name resolution. So tracert space -d, then space www.google.com. So the output of this command would display that how many hosts away your destination application or your application is. Like currently, if you look at here, my destination host is Google, right? So Google is 9 hops away from me. Google is 9 hops away from me. So that's the meaning of this traceroute command or tracert command. So that's the use of this tracert command to identify that how many hop away our application server is. So Google is 9 hops away from us, from my laptop. Okay, so that's tracert command. You also can run couple of more commands here in command prompt itself, like ipconfig. This command is used to get the IP details. So if you want to identify the IP details of your laptop, which is running Windows operating system, then in command prompt you can run this command called ipconfig. So once you run this command ipconfig, like I have got a wired like Ethernet adapter, but that's not connected. But I've got my wireless adapter or wireless LAN adapter, which is currently connected, and you could see that I have got this IP address. So if you look at here, this is the IP address that we got or my laptop currently has. So my laptop has got this IP address. This is the subnet mask and this is default gateway. Right? So this is my default gateway here. Remember, the IP addresses are always represented. I'm talking about the IPv4 addresses. So IPv4 address will always use the decimal number system. It will use what? Decimal number system, but it is basically dotted decimal. See, each block is separated by the dot. Total 4 blocks are there in IPv4 address, as well as there are 4 blocks in subnet mask, as well as it is same for the default gateway. Now, if you want to get more details, then the command would be ipconfig and then /all. The output of this command would display a complete information of your interface or LAN adapter. So this is wireless LAN adapter. So not only it has got IPv4 address, but also subnet mask, and also it has gateway, and also it has got the DNS server. This is my DNS server. And not only that, but also it will display you the physical address, which is the MAC address of this interface. And then the description of this wireless LAN adapter will display that, okay, this wireless LAN adapter belongs to Realtek. That's the manufacturer of this network interface card, which is currently installed on my laptop. So this is how things this is how you could look at the things using CLI. And then not only that, but also sometimes you might want to look at the ARP table. So that's ARP space -a. The output of this command would display the ARP table available on your laptop. Now what it does or what is the use of ARP table, that's something that we will learn later on. But I'm just trying to make you comfortable with the operating system. Now, if you want to set up an IP address on your network interface card, I would suggest you to open the network interface properties. And to do so, there is a command that you could run in your command prompt, which is ncpa.cpl. Run this command and then this network connections would open, and then you could go to wireless network, right click on it, then go to properties, and then you could select internet protocol version 4 TCP/IPv4. Select that option, then click properties. Now you could see that I have configured my laptop to obtain an IP address automatically, and in that case DHCP will be used. DHCP stands for dynamic host configuration protocol. So this my laptop, right, is currently configured to obtain an IP settings automatically, and obviously we are using DHCP for that purpose. Even at home, you are using the same settings. Like if you look at your own laptop, you can easily find these settings available on your laptop, that you are trying to obtain an IP address automatically from DHCP, right? And then you could also validate your IP address by running this command ipconfig. So this is the IP address that I have got from my DHCP server. Okay, well, this is how you could you could see or you could look at some basics of your operating system when it comes to the networking, because obviously you would require to set up your network adapter on your laptop, whether you are using the physical network interface card or physical network adapter, or you are using a wireless, I mean in place of wired network adapter. If you are using wireless network adapter, still you have to allocate IP addresses and all that. Or maybe you might want to configure the IP address using DSCP, so you can automate that. Well, let's get back to OSI model now. This is where we were actually. Let me go back. I just wanted to show you some basics of the operating system where you could check your own IP address. So yeah, the OSI model, that is also known as Open System Interconnection Model. So basically, this OSI model is responsible to explain us that how traffic is going from one system to another system, like from one laptop to another laptop, or maybe from laptop to your printer, or vice versa, from a laptop or from a client machine to the server, or maybe from server to your client machine. So it would explain us that how traffic is going. So OSI was developed by ISO, which stands for International Standardization Organization. That's ISO. Whereas TCP IP model was developed by DoD, Department of Defense in US. Basically, before TCP IP model, it was known as DoD model. But then later they renamed it as TCP IP. But again, the background of the TCP IP model also lies on OSI model. So you could see that basically what they did was they combined upper three layers like application, presentation, session as a single layer called application layer. Transport is still transport, the network is still internet, whereas data link layer and physical layer, those two are combined together into a single layer called network access layer, and that's what makes it TCP IP model. So if you look at here at higher reference level, even that, even for TCP IP model at higher level, the reference was taken from OSI. Now again, OSI is a reference model, whereas TCP IP model is an actual implementation which we use to transmit data using an internet. As I told you before that we don't use OSI model. OSI is just a kind of reference model, whereas TCP IP is something, I mean, this is the model that actually we are using. We just saw that. Even we found that when we try to open up the network interface settings or properties, the network interface properties, we saw that we had an option for TCP IP model, not for OSI model. So the actual model that we use, that we implement, is TCP IP model, whereas OSI model is just being used for the reference purposes nowadays. So as I told you that OSI has got like 7 layers: the application, presentation, session, transport, network, data link, physical. So if you are studying the OSI model from a sender point of view, so sender will generate some data application layer, then it is given to the presentation layer, then it will be given to session, then it is transport, then network, and then data link, and then finally your data will be placed onto physical media. Whether it is a wired network, then it will be placed on the wire. If it was a wireless network, then it will be placed onto a wireless network. But finally, traffic would be sent out from the machine over the physical media. Until data link layer, the data is still on your local machine, on your laptop, on your desktop, on your cell phone. But then once it moves on to physical media, which means the data has left your machine now. The original TCP IP model was as this, like application, transport, internet layer, and network access layer. But normally, nowadays we talk about the modified TCP IP model only, because application is, and here, look at here, right? Application is still application, transport is transport, internet is internet, but this network access layer is still like data link and physical link. So we haven't left this data link layer. We are still using it separately. So basically, this is called modified TCP IP model. So basically, in production environment, you would always understand the data flow or traffic flow based upon the modified TCP IP layers. So the only difference between original TCP IP and modified TCP IP layers is just that network access layer is divided into two sub layers like data link layer and physical layer. That's the only difference. So basically nowadays we always talk about the modified TCP IP model. This is how the data is transmitted using a layered approach. So your data always starts from application layer. Remember, your data always starts from application layer. Then it is given to the transport layer. At transport layer, you would use either TCP or UDP. Ideally, these are the only two options to choose from, either TCP or UDP. If it was TCP, then TCP header will be attached and then it is given to the network layer. At network layer, again, you have got many protocols that you could use like IPv4, IPv6, or many others. But IPv4 is the most common one. So IP header will be attached and then it will be given to the data link layer. Then at data link layer, the header and trailer both will be attached. You could see that. I have been, I've been saying that that header and trailer both will get attached on top of your data, and that's how it becomes frame, and then finally it will be placed onto your physical media. So this is your data link layer. So if you look at this, this is your application first of all at top, and this is your transport layer, this is network layer, and this is your data link layer, and finally you have got this is called encapsulation. So this, basically, if just imagine that if we never had this layered approach, how we would have understood this flow then. So basically this layered approach, enables network administrators, it enables us to understand that how exactly traffic is flowing. So at first the application header will be attached, at second transport layer header will be attached, then third from a sender point of view. Now remember, this is from sender point of view, but from a receiver point of view, you will always perform decapsulation, right? What is the benefit of layered approach or learning these layers? It prevents changes in one layer from affecting the other layer above and below. That's one advantage. Let's say you modified something at network layer, which means that you're not affecting your transport layer or data link layer. It provides a common language to describe the networking function and capabilities. So if you have a kind of a standard mechanism, right, like this, like layered approach, which means that we can use the same approach to understand and even to explain that the functions of your device, like if it is a router, if it is a switch, whether it is from Cisco or from Juniper, because all these devices, although they are from different vendors, still they will have to follow this layered approach. Okay, easy to understand, like how traffic is going and how traffic is being received, that is also becomes easier for us to understand. Okay, so that's the advantage of having the layered approach. So the whole process is divided, like when you send the data or maybe receiving data, the whole process is divided into multiple steps, and those steps are called layers. Now if you take an example of the OSI layer, right, so as I told you that obviously there will be a transmitting device and then there will be a receiving device, which means that one will be sender, the other one will be receiver, right? So if you look at the sender, right, so sender is sending data, but starting data from where? From application layer, right? Then each layer is attaching its own information on it, which is also known as header. And finally, data will be placed onto physical media. The receiving device will receive the data at physical layer itself first. First, it will receive data at physical layer, then given to data link, then network, then transport, then session, then presentation, and then finally it is given to the application layer. But one thing you could see here, that the sender is performing encapsulation because it is attaching header at each and every layer, whereas the receiver is decapsulating because it is removing the headers at each and every layer. You could see that. Okay, so that's your layered approach as per the OSI model. So in OSI model, you had all these 7 layers. So sender will perform encapsulation, and at each layer we are attaching the header, although it will be depending on protocol. Like if you are using, let's say at layer 3, which is also known as network layer, right? So if you are using IPv4, so there will be IPv4 header. If you are using IPv6, then there will be IPv6 header. If you are using GRE, then GRE header will be attached, or maybe something else, right? Similarly, it applies to the transport layer. If you are using Ethernet, then Ethernet header will be attached. If you are using frame relay, then frame relay header will be attached. If you are using triple P, then triple P header will be attached on your data. Same goes with transport layer. If you are using TCP, TCP header. If you are using UDP, UDP header will be attached. If you are using a CTP or something else, then those headers will be attached. Okay, so it depends like which protocol you are using at which layer of the OSI. We will also talk about that in more details. Don't worry. So the same layer interaction happens between different computers when two computers interact. Example, network layer at sender will interact with the network layer at the receiver. So this network layer will interact with this network layer at the end of receiver. Why? Because if sender is sending some data through the network layer, it will attach some sort of information and then it is given to the receiver, and receiver will receive that network layer information, and based on that only it will receive the data. So ideally at network layer, you provide the IP information to your data, like what is source IP, what is destination IP, and all that. So adjacent layer interaction happens within the same computer. when data is passed from one layer to another layer. Like I gave you an example, from application to presentation, from presentation to session, then to transport, then network, then data link, and then finally physical layer. Make sense? So that's that. So from a sender's point of view, it will go from upper to lower, whereas from receiver standpoint, it will go from lower to upper. The upper layer is always application layer. So now we have to understand the function of each layer, right? And the very first thing that we are going to cover now is the physical layer. Like, how does it look like? How does physical link or physical layer look like of a network? And let me tell you one more thing. You can only see the physical layer. Like with your eyes, you can, what's visible is just your physical layer, because you can see your switches, you can see your cables, you can see your hubs, you can see your laptop desktop, you can see them interconnecting using cable. So physical layer is something that you can see by your eyes, or you can touch, you can feel. But other than that, any other layer cannot be cannot be seen. The physical layer is something that you can see by your own. Now physical layer is the very first layer in OSI model, from bottom to top. Like if you're studying from a receiver point of view, from a recipient point of view, like say receiver is receiving data. So when receiver is receiving data, it will receive data using physical layer first. So that is why we call it first layer of the OSI model from a receiver standpoint. So at physical layer, it consists of hardware and topology. So as I told you, hardware, you can see them, like you can see switches, you can see hubs, you can see laptops, desktops, maybe wireless access point, maybe wireless controller. So these all devices can be seen. Those are physical devices, those are hardware devices. And then even the topology will be defined at this layer only. So if you talk about the hardware components, so obviously you have got laptops, you have got desktops, you have got maybe a hub, you have got a switch, you have got the physical cables. So that's that. You have got hardware components such as transmission media. Transmission media could be either guided or unguided. I mean, transmission media could be of guided or unguided, not cables. The transmission media could be either guided media, which is a wired network, or cable based networking, and unguided is a wireless network. We use wireless a lot nowadays. Earlier it was not that famous, but nowadays we use wireless a lot. I would say approximately everywhere you can find wireless network, wireless infrastructure nowadays, along with the wired network. And I've been observing this from a long time now, that not Cisco, the laptop vendors have stopped providing the physical RJ45 port. Have you observed this? That on personal laptops, I'm not talking about the ThinkPads, I'm talking about the personal laptops. Like you go to HP and ask them to give you a personal laptop, not a ThinkPad kind of thing. So if you buy a personal laptop, you don't get the RJ45 port anymore. Have you observed this or not? I'm asking you all.
Yes, sir.
So you are getting only wireless network, right? Available on your laptops nowadays. Or maybe you will have to have a converter from RJ45 to USB, so that you can have a physical connection to your laptop. Not only you have cables, but also you have got connectors. I will talk about those cables and connectors in more detail later. And the topology is there. Like this topology is called bus topology. If you look at kind of bus, and then it's a shared bus, shared media. Everybody is connected to that shared media, right? So this is called bus topology. Then star topology is also there, like this, where ideally we use the star topology between switches to interconnect switches together. So ideally you would have your switches interconnected to each other in a full mesh. So it's not a star, basically it's a full mesh. Star is right there. So this is a star topology, like each and every component, like your laptops, desktops are connected to a switch. So this is called star topology. So it's kind of a star, and this is your bus topology. We don't use this bus anymore. Earlier we had this option because we used to have the hubs. We don't use hubs anymore. We use only switches, and all switch ports, like ports on switches, comes in a full duplex mode nowadays. So even you are not using half duplex. So if you are not using half duplex, which means that all the machines can send data at same time, they can also receive the data.